to Maheshwari chemistry classes. Today our topic is intermediate second year, very important VSAQs. In this already part 1 is over, this is a part 2, so listen properly. I don't want to waste your time, so please give me your support. Please like and share, subscribe my channel. So listen carefully better. Next question, define osmotic pressure. Okay, osmotic pressure means first osmosis prevention purpose, osmosis process prevention decrease purpose applying pressure is known as osmotic pressure. First of all, osmosis means higher concentration water area to lower concentration water area, the particles will move. Okay, the water particles will move, that is known as osmosis. This osmosis prevention తగ్గించడానికి, okay, osmosis prevention purpose applying pressure is known as osmotic pressure. Okay, especially osmotic pressure is indicated with the pi. Okay, pi decreasing extra pressure, that's it. Next question, what are isotonic solutions? Especially these similar words have a confusion, right? So that is why I wrote at a place. So listen carefully. What are isotonic solutions? Same osmotic pressure containing solutions at a given temperature is called isotonic solutions. Means pi value is same for the isotonic solutions. Especially blood is isotonic with the saline water. ఓకే, సో డిహైడ్రేషన్ అయినప్పుడు సెలైన్స్ ఎక్కించారు అంటారు కదా, అందులో సోడియం క్లోరైడ్ రిలేటెడ్ సొల్యూషన్స్ ఉంటాయి. అదే సెలైన్ వాటర్ 0.9% సోడియం క్లోరైడ్ సొల్యూషన్ ఈజ్ నోన్ యాజ్ సెలైన్. ఇట్ ఈస్ దీస్ సెలైన్ వాటర్ pi value, I mean osmotic pressure value, our blood osmotic pressure value, both are same. This kind of solutions are known as isotonic solutions. Simple, same pi value solutions at a given temperature is known as isotonic solutions. That's it. Okay, next question, states Henry law and Raoult's law. Actually single question as a VSAQ, but at a time I want to explain this with a small variation. These both are looking like same. Once you check this, the partial pressure of the gas in a vapor phase is proportional to the mole fraction of the gas in the solution. Simple, if you take a graph, on x-axis we have to take the mole fraction and y-axis we have to take the partial pressure. This partial pressure of the gas at a given temperature directly proportional to the mole fraction. Okay, so it like a guy, P is equals to, if you remove this directly proportional symbol, P equals to KH into X. Next, Raoult's law, the RLVP, relative lowering vapor pressure of a dilute solution containing non-volatile solute is equal to the mole fraction of the solute, P naught minus PS by P naught equals to X2. Okay, so like this we have to write a same as it is here also. On x-axis we have to take mole fraction and y-axis we have to take the RLVP of dilution solution. Okay, containing non-volatile solute. This here RLVP we have to take, here mole fraction we have to take. These are directly related. This is known as Raoult's law. Where Raoult's law is came, that time you have to write RLVP of dilution. Okay, dilute solution. Henry's law purpose, directly partial pressure of the gas in vapor phase. Okay, that is the variation. Here Henry's law purpose, P equals to KH into X. Here Raoult's law purpose, P naught minus PS by P naught equals to X2. That's it. Both graphs are same as it is. Next, one more important definition. What is metallic corrosion? Okay, or corrosion. Metallic corrosion is a gradual decrease or destruction of metal surface or metals by the reaction with the moisture in the atmosphere. Simple, iron తో పోటడము, ఓకేనా, కొన్ని రోజులకు వెండి వస్తువులు నల్లగా అయిపోవడం ఉంటాయి కదా. ఓకే, అది ఏంటిది మెటాలిక్ కరోజన్కి ఎగ్జాంపుల్. ఓకే, మెటాలిక్ కరోజన్ మీన్స్ metal surface destroyness. How it is happens? Gradually, slowly happens. Okay, why? When the metal is reacted with the atmospheric moisture. Okay, so example is rusting of iron and tarnishing of silver. It is also important bit. Silver metal corrosion is known as tarnishing, iron metal corrosion is known as rusting. Okay, especially metal surface destroyness is nothing but a metallic corrosion. Okay, when it is happens, when it is reacted with the moisture. This moisture will come from where? Atmosphere. That's it. Okay. Next, one more important question. What is SHE? Okay, it is not she. It is a full form. We have to write standard hydrogen electrode. Okay, SHE means standard hydrogen electrode. Here EMF known electrode also, electromotive force known electrode also known as standard hydrogen electrode. Here potential value is a known electrode. Simply that is known as standard electrode. Standard electrode nothing but that EMF already we know. Okay, so here standard hydrogen electrode potential value 0. It is also important bit for MSET mains, whatever you write, NEET or whatever the exam, but also IP VSAQ purpose also important question. Next question, what is galvanic cell or voltaic cell? Give an example. Galvanic cell or voltaic cell nothing but a device which converts the chemical energy into electrical energy by redox reaction is called the galvanic cell. Chemical energy converts like a electric energy. Redox reaction nothing but at a time oxidation condition is there, redox condition is there. Okay, so next important question, what is electrolysis? And state Faraday's first law and Faraday's second law. Individually they will give as a VSAQs, or combinedly they will give as a SAQ, or sometimes SAQ not possible from the electrochemistry. So Faraday's laws, electrolysis and one formula combinedly they will give as a LAQ. Anyway, you have to learn as a VSAQs each and every single title. So next, electrolysis, that chemical decomposition of electrolyte by current is called electrolysis. Okay, for example, if you take molten sodium chloride, okay, when it is passed through the electricity or nothing but current, it separates as a sodium and chlorine gas. Next, Faraday first law trick box purpose, check this. Amount of substance is directly proportional to the quantity of charge. W is directly proportional to the Q. Next, Faraday second law, different substances amount W1 by W2 is directly proportional to the chemical equivalent weights of the electrolytes, that is E1 by E2. Simple. This is the trick box you have to remember for the Faraday first law and Faraday second law. Okay, this is about electrolysis, Faraday first law, Faraday second law. Okay, next, Faraday first law, the amount of substance deposited or liberated directly proportional to the quantity of electrical charge passing through the electrolyte. Okay, so when the electrode is dipped in a electrolytic solution, if you take like this, okay, so single electrode purpose we have to write the first law, both electrodes purpose we have to write the Faraday second law. Here first we have to check this Faraday first law. Okay, this electrode containing here on electrode is either it may be deposited or it may be liberated. Okay, amount of the substance, that quantity, that amount is directly proportional to the quantity of the charge. Okay, the W is directly proportional to the Q. Next, Faraday second law. Here Faraday second law purpose, when the same quantity of current passing through the electrolyte solution, the amounts of different substances liberated is directly proportional to their chemical equivalent weights. Here we have to take the two electrodes when these two are dipped in the two electrolytic solutions, but the same quantity of the current is passed through. That time what happens, W1 by W2 equals to E1 by E2. Same here also, amount of substances directly proportional to the charges of that electrodes. It is nothing but chemical equivalent weights. బాబు నాకు ఎడిట్ చేయడానికి టైం దొరకదు, సో ఎట్లా ఉంటే అట్లా అప్లోడ్ చేస్తా, ప్లీజ్ ఎక్స్క్యూజ్ మీ. నెక్స్ట్ వన్ మోర్ ఇంపార్టెంట్ క్వశ్చన్, how is chlorine manufactured by Deacon's method? Okay, for this purpose 3 types of different equations we have. Anyone you have to learn. In this one of the equation is Deacon's method. In this method, chlorine is obtained by the oxidation of a HCl gas by atmospheric oxygen in the presence of copper chloride catalyst at 723 K. Simple, hydrochloric acid react with the oxygen gas in presence of copper chloride catalyst and 723 K temperature. It convert like a chlorine gas or nothing but chlorine preparation purpose. It is an important technique, that is a Deacon's technique, and it releases a H2O. This is the byproduct, no need to worry. Here a main product is a chlorine. Chlorine preparation is a Deacon's technique. 2 types of techniques we have. Electrolytic method is there and Deacon's method is there. In this Deacon's method, this is the procedure. Next, MnCl2 based one type of reactions are there. 2 types of reactions are there. Total 3 types. Anyone you have to write. Okay. Next, Write any two uses of argon. Okay, you may expect this kind of question also, and it is also important for MSET also. Argon is mainly used to provide the inert atmosphere at high temperature, in a high temperature metallurgical process in the laboratory for handling substances that are air sensitive, filling electric bulbs. Okay, and sometimes they will ask neon uses also. At a time I want to explain, listen carefully. Neon and argon uses purpose, tick box, discharge tubes, fluorescent bulbs, filling purpose, advertisement display, advertisement boards containing that lights are there, right? When we are traveling on the road, that sides advertisement display boards are there. Okay, so those are also filled with the neon gas. Next, botanical gardens. Okay, that botanical gardens decoration purpose also they will use the different types of lights, right? That lights also filled with the neon gas. And greenhouse gases. Next one is argon uses. Inert atmosphere means atmosphere is absent, no gases creation purpose. Okay, inert area preparation purpose, inert atmosphere preparation purpose, especially where it is used in metallurgy. Okay, they will use argon, and in lab handling purpose, air sensitive substances purpose, they will use argon gases. Next, argon uses, it is filled in the electric bulbs also. Okay, so these are the argon and neon uses, important MCET bits. Next, one more question, in very important question, we may expect this kind of question. In modern diving apparatus, a mixture of helium and oxygen is used. Why? ఓకే, ఇప్పుడున్న మోడర్న్ డైవింగ్ ఆపరేటర్స్లో ఆక్సిజన్తో పాటు హీలియం కూడా మిక్స్ చేసి యూజ్ చేస్తున్నాం. ఎందుకు? సింపుల్, వెరీ లో సాల్యుబుల్ ఇన్ బ్లడ్. ఓకే, హీలియం ఎప్పుడైతే యాడ్ చేస్తామో అది స్లోగా సాల్యుబుల్ అవుతుంది బ్లడ్లో, అందుకోసమని. మరి ఇట్లా స్లోగా సాల్యుబుల్ అవ్వడం వల్ల లాభం ఏంటి అంటే, సింపుల్, ఎప్పుడైతే మోడర్న్ డైవింగ్ ఆపరేటర్స్ ఎక్కడ యూజ్ చేశారు? సీ కానీ, సముద్రంలో కానీ, మహాసముద్రంలో కానీ ఈత కొట్టేటప్పుడు వాళ్ళు సిలిండర్స్, ఆక్సిజన్ సిలిండర్స్ క్యారీ చేస్తే వెళ్తారు కదా. వాళ్ళు ఎప్పుడైతే సడన్గా పైన వైపుకి వస్తారో, సర్ఫేస్ ఏరియాకి వస్తారో, భూమి పైనకి రావాలనుకుంటారో, అప్పుడు వాళ్ళకి హై ప్రెషర్ ఒకేసారి వాళ్ళ బ్లడ్ వెజల్స్లో ఇంక్రీజ్ అయిపోయి ఆ బ్లడ్ వెజల్స్ నుంచి బ్లడ్ బ్లీడ్ అవుతుంది బయట వైపు. అప్పుడు పర్సన్స్ చనిపోతారు. దాన్ని బెంట్ డిసీజ్ అంటారు. ఓకేనా? సో ఆ హై ప్రెషర్ ఒకేసారి ఇంక్రీజ్ అయితే బ్లడ్ వెజల్స్ పగిలిపోయి బ్లడ్ బయటకు వస్తుంది కదా. సో అలా అయితే పర్సన్ చనిపోయే అవకాశం ఉంటుంది. సో అలా హై ప్రెషర్ కాకుండా స్లోగా సాల్యుబుల్ అయితే, ఓకేనా, ప్రెషర్ అనేది అంత ఎక్కువగా ఇంక్రీజ్ కాకుండా పర్సన్స్ అనేవాళ్ళు సేవ్ అవుతారు. అందుకోసమని ఈ మోడర్న్ డైవింగ్ ఆపరేటర్స్లో ఆక్సిజన్తో పాటు హీలియం మిక్స్ ఇస్తారు. అరబిక్ బేటా सुनो, मॉडर्न डाइविंग ऑपरेटर्स में ऑक्सीजन के साथ साथ हीलियम क्यों मिक्स होता है बोल के, ये ओशन और सी में, okay, then they will do the swimming, no problem, but when they will come outside from the water, ओके, ऑटोमेटिकली प्रेशर बढ़ जाते बेटा. प्रेशर बढ़ जाने के टाइम में वो पर्सन का ब्लड वेजल्स में भी प्रेशर एकदम बढ़ जाके वो वेजल्स से खून बाहर आते. ओके, सो ये डिसीज़ को क्या बोलते बेटा? बेंट डिसीज़ बोलते. ओके, समटाइम्स इट मे बी डेंजरस. ओके, सो दैट इज़ वाई दैट कंट्रोलिंग पर्पस दे विल मिक्सिंग द helium gas. Okay, so here especially helium, when it is mixed, it's low soluble in blood. Okay, pressure एकदम नहीं बढ़ जाती. It cannot increase directly. I mean pressure controlled. I mean pressure may be moderate when we will use the helium. Okay, helium very low soluble in blood. Okay, simple, you have to remember this line, but this is the in-depth what happens when we will mix it helium. Okay, simple beta, remember helium and oxygen combination is used in modern diving operators because helium is low soluble in blood. Simple, you have to remember this word, low soluble in blood. Okay, अगर पूरा एक्सप्लेनेशन चाहिए तो ये रिमेंबर करो. नेक्स्ट, वन मोर इम्पोर्टेंट क्वेश्चन, what is home signal? Calcium phosphate and calcium carbide mixture is called as home signal. It is packed and then thrown into the sea. Easily it catches the fire, burns with the luminous flame. It works like a signal to the approach ship. ఏం లేదు బేటా, సింపుల్గా కాల్షియం ఫాస్ఫేట్ని కాల్షియం కార్బోనేట్ మిక్చర్ని ప్యాక్ చేసేసి దానికి ఒక చిన్న పిన్ హోల్ పెట్టేసి, చిన్న హోల్ చేసేసి వాటర్లో ప్యాక్ పడేస్తారు అనమాట. అప్పుడు ఏమైందంటే ఎప్పుడైతే వాటర్కి ఈ కాల్షియం ఫాస్ఫైడ్ కాల్షియం కార్బోనేట్ మిక్చర్ తగులుతుందో అది ఇమ్మీడియట్గా మంటల్ని వెదజల్లుతుంది. అంటే వాటికి రోడ్లపైన వెళ్ళే వాళ్ళకి ట్రాఫిక్ సిగ్నల్ గ్రీన్ ఎల్లో ఇట్లా రెడ్ ఎట్లా కనిపిస్తుందో ఆ వాటర్ బాడీస్లో ఉన్న వాళ్ళకి ఆ వెలుతురు అనేది ఒక సిగ్నల్ లైట్ లాగా ఉపయోగపడుతుంది. ఓకేనా. సునా బేటా అరబిక్ బేటా a calcium carbonate and calcium phosphate mixture, okay, water when they thrown into the water, it will automatically it catches the fire. Okay, so that time it will work like a signal. Okay, so it is useful for the ships. This is known as a home signal. What is that home signal? Calcium phosphate and calcium carbide mixture. Next, explain antiferromagnetism with suitable example and F centers and ferromagnetism and ferromagnetism. For this purpose I can give wonderful trick to you. So first listen properly. Explain antiferromagnetism with suitable example. The substance's magnetic momentum of domains are aligned in parallel and anti-parallel is equal to the number of the net value mu is 0. Simple. This already you have an idea. Upper arrow mark is a positive and lower arrow mark is a negative. Here plus and minus both are there. Plus half minus half, that is a mu value is 0. Okay, antiferromagnetism showing compounds are MnO and MnO2. Okay, here magnetic momentum value 0, parallel anti-parallel equal number is there. Okay, next, what are F centers? The metal excess defect is due to anion vacancy. That vacancy sites are occupied by electrons are called F centers. Simple beta, you have to remember like this. The metal positive or same as it is, but anion places or vacant places are there. Okay, that vacant place is compulsory filled with the minus only, but in the place of minus charge electrons are filled. This kind of metal defect is known as F centers. F centers when increases automatically color and magnetic properties increases. Okay, simple one word definition. Anion vacant sites are filled with the electrons. This kind of metal defect is known as a F center. When F centers increases, color property, magnetic property important. All these are important for MSET and IP board exam VSAQs. Okay, next, explain ferromagnetism with suitable example. The substances mu of domains are aligned parallel and anti-parallel direction is unequal number. These are weakly attracted by the external magnetic field compared to the ferri weak. Okay, so compared to the ferri is weak. Okay, for example Fe3O4 and MgFe2O4. Okay, here positive side negative sides are there, but somewhat single electrons are more, means somewhat paramagnetic nature. Okay, paramagnetic nature, nothing but like a ferromagnetic nature. Next one is explain ferromagnetic with a suitable example. In these substances all electrons are aligned in the same direction, strongly attracted by the external magnetic field. Okay, strongly attracted with the external magnetic field. Number of single electrons are more. Example, iron, cobalt, nickel. These are the ferromagnetic. Okay, బలమైన అయస్కాంత పదార్థాలు ఫెర్రో. ఓకే, బలహీనమైన అయస్కాంత పదార్థాలు పారా. Another name is a ferri. Okay, next, anti-ferro means dia. This is a trick. Yes beta, check this trick once. Anti-ferro dia, ferri, para, ferro. Okay, means strong magnetic nature. Okay, strong attraction with them. No attraction here no attraction